Were you saying something?
Oh, I was just saying good morning.
Oh, good morning. Sorry,
I
I thought I was connected, but I wasn't.
oh okay. I saw your PR merged. That's
Oh,
great.
yeah. Yeah. I on one I discussed with Josh and was taking a look why perf was failing. I think still classical OSD the perf tests are failing for um, Jenkins. So I I was just wondering what was the cause.
Sure. I don't know. I've been kind of, helping out on the sideline with that, but I'm not sure what the current status is.
Yeah. Josh
I've
said that
been very oh,
it's
go ahead.
still in progress. Josh was saying that it was just a day or two old when it was merged, so maybe it's still a baby right now.
Yeah. Yeah. I've been very neck deep in the encoding and MDS journaling. Uh, I don't know what you want to call it. I guess discussion or well, we're trying to make it better. So I've been
Yeah,
very distracted.
even for IO 500, I saw that you guys were working on weekends and
Yeah,
um,
yeah. So I
okay,
slowed down a little this week, and now I'm kind of taking it a little easier.
that's great. It's good to know that there is some competition. We can benchmark ourselves.
Yeah, and the previous list, I think Suze had just kind of thrown something together quick for it. And it's we didn't do that well compared to a lot of the other ones, but I think this round will at least have something more competitive. And then I'm hoping in the fall with some of the things that Radek is working on and Patrick and Kifu and other people, maybe we'll do really well on it. We'll see.
Fingers crossed.
All right. Well, it looks like we've got folks now. So good morning, everyone. Let's get the meeting started. All right. Pull requests. I did not see anything new when I was looking through the pull requests this morning. I might have missed something, but it looks like, at least for the moment, not a whole lot new going on. We did have a lot of stuff closed though in the past 2 weeks. Um, the Dipika's excellent PR for looking at finer grained mempool statistics that merged, and maybe even more than just statistics, but rather the categorization of those of how we're using the mempools. Um, let's see. Also, this pending IOs instead of IOVEC size for Iosnum that merged by Kifu. Um, there was a PR that Matt Benjamin merged that was using XX hash for GCQ selection. I confess that I only very briefly skimmed what that was, but it seemed good, so I'm glad it merged. Um, Igor's excellent onode pin unpin simplification PR merged. So that's a big win, I think, because it goes on to improve on the stuff that I was trying to do to improve on the original pin unpin logic in the Blue Store cache. And this, I think, kind of gets us into the place that we want to be with it. So that's really good. Glad to see that merged. Um,
A quick question. We should probably backport that to Octopus, right?
do you know, Niha, did my PR merge to get backported to Octopus?
I thought your PR merged in Octopus and then
Oh yes, you're right. Yep. Sorry, I was thinking Nautilus. Um, yeah,
I
yes,
in
that
fact
should.
saw one of those bugs that we have associated with that yesterday on Octopus. So that's what also reminded me that maybe Igor, do you see any issues with it? think I'm seeing Igor on the list, but maybe he's muted or something. But in any case,
Yeah. So sorry. So yeah, it makes sense to backport it to Octopus one day, but I suggest to bake it for a while, just to make sure it's free of bugs. Okay.
sure.
Yeah, Neha, I agree 100%. Let's get that in Octopus as soon as we feel good about it.
Cool.
All right. And then, there's an old PR from Kifu about using a transparent comparator that just got closed by Stalebot. So if we are interested in reviving that, it's there. There were 3 PRs I saw that merged in that were updated in the last 2 weeks that were not closed. The first one is optimizing the lock of BlueStar writing process. So that's the one that we need to review. Yeah, that one we should figure out how comfortable we feel with it. Theoretically, I think it's passing tests now. Then there's my PR for the MDS that adds the expected files xadder for directories, and then also adds a flag that lets you specify that they are going to be hot, which then splits those directories into pre-exports those directories to different MDSs. So the first part will pre-fragment the directory, and then the second part will pre-export those fragments in a pseudo-random fashion out to the other MDSs. That PR got rebased on top of the work that was done for the ephemeral pinning. And the only thing that's a little weird about it now is that the performance when you only pre-fragment the directories appears to be far worse than it used to be. When you also are doing the pre-exporting, it's about the same as it was before, but it's a strange case, and I'm not sure why it's slower now. So I need to figure that out. But in any event, that's there. And then the last PR here is enabling RocksDB pipelined writes. So RocksDB for the last couple of years has had this capability. It was not there when we initially wrote BlueStore. It looks like in Adam's testing, he didn't see a lot of performance benefit. In Majian Peng's testing, he saw a significant performance benefit when BlueStore buffered IO is used. But since we are now disabling that and probably are not going to be re-enabling that anytime in the near future, it looks like the gains from this are more modest. Having said that, though, the fact that we're seeing gains and we're seeing even more gains in other situations means this is probably worth doing. It may enable future gains that we just don't see right now. So I think we probably do want to do this. We just need to review it and figure out if we are comfortable with it. So there's that one. And then we've got not a huge list of no movement compared to what we've had in the past, but we do have a number of PRs here that have not been updated in the last 2 weeks, at least a couple of which are mine. So anyway, that's it for PRs. Any questions on that or anything I missed? All right, well then let's move on. So first order of business is I did not finish slides for the IO5 program presentation I've been working on. I was last week I put in a lot of time and over the weekend on getting the results going, so I kind of slowed down this week. So next week, hopefully I'll have something ready and we can go over stuff then. But having said that, as part of all of this IO500 testing, what really kind of came to the forefront is that when you have active NBS configurations, we see significant overhead in the journaling code on the authoritative MDS. And I kind of, about a week ago, made a mad dash to see if I could switch it all over to DENK, which is the encoding framework in BlueStore that was created a couple of years ago to help improve encode decode performance. But it's kind of parasitic. It started out in the MDS, but then it started sprawling, requiring encoding changes all over the entire code base, especially stuff in common and include. And so it ended up becoming this monster that wasn't really viable. I was getting really worried about introducing bugs and having other problems. So there's two separate things going on related to that now. Hifu took a stab at seeing if we could make the DENK not parasitic, so you could change something in one place without having to change every single contained type as well. And I think he was maybe making progress on that, but it still has some shortcomings. It's not going to be any faster until every single contained type is also converted. So we might be able to make it iterative in terms of changing it, but it won't actually really improve things very much until we go through the entire code base. So there's that. Radek also brought up that the downside of the DENK framework is that it requires you currently to walk through the entire encoding structure and pre-calculate the size of everything. In BlueStore, that's been a win relative to making lots of small memory allocations usually, but it's still not ideal. And it's worse the more contained types you have, the bigger kind of giant encoding hierarchy that you have. So there's that as well. So Radek and I spent some time last week, several hours actually, going over talking about whether or not we might be able to use the existing encoding framework where we don't make any kind of predictions about how big stuff is, but instead, maybe if we have lots of short-lived buffer lists, which we do in various parts of the code base, maybe we can allocate most of that memory from a circular buffer or multiple circular buffers, a per thread circular buffer, that then will allow us to avoid going back to tcmalloc and asking us that for all these little small memory allocations that can be fragmented all over the place. So here instead, we're using this contiguous circular buffer, allocating mostly in order, or always in order, and then hopefully deallocating mostly in order so that we can continually use it. If we end up in a situation where we can't allocate from that, maybe then we go back and just do a standard allocation from tcmalloc, but hopefully that's more rare so long as we don't let stuff persist in the circular buffer on a for very long periods of time. So Radek started working on that. And Radek, I wanted to ask you first, if you could go over what you started in on, like you did at the stand-up earlier today. Then I had questions for you about it, if that's okay.
Sure, let's start. Okay, so the brief idea is about leveraging let's start from the assumption we made. We assumed that basing on the profile made by Mark that showed that the encoding in MDS requires a lot of allocations that spends plenty of time in the allocator, in refill buffer space of buffer list, which is basically just a thin wrapper over tcmalloc's POSIX mema line. We saw that the huge number of cycles is burned there. So we started researching how much of the work that is performed by TC is really essential. I mean, essential from the point of view of our very specific use case. I don't have any good idea to estimate that besides implementing the raw type and giving it a benchmarking. That's what we are doing. Maybe if the ratio between the essential work and well, if tcmalloc does a lot of extra work only for the sake of being, let's say, generic and POSIX compliant, then a fine-tuned buffer row implementation for buffer list maybe could help with that. But it's a speculation, to be honest. However, I started implementing this stuff, and here is a snippet. At the moment, it's just it's not a code. It's just a sketch. It's just a mock-up. But hopefully it will show the idea behind the data structure for this new row type. Cache ring T is assumed to be a thread local variable. So if a new allocation request made because of encoding the stuff in MDS is issued, it will be handled by a thread dedicated memory cache. Something like is already present in tcmalloc. But in tcmalloc we saw that actually the cache gets exhausted, and there is memory flow happening. In our bet is that this is pretty costly. Well, it's very costly operation in tcmalloc, but in our local allocator, maybe we could optimize that case. That's the reason for trying a design based on actually a ring buffer. The allocation part will happen. It's actually single threaded, but that's not the case of the allocation. We still need to assume that it must be multi-threaded. That's because of how data flows very likely looks like in our daemons. I don't know the exact implementation MDS, but I'm trying to extrapolate my knowledge about OSD. In OSD, you have a thread pool consisting of all workers, TP, OSD, TP. Those guys are usually doing the marshalling, doing the encoding. The memory with encoded stuff, however, is finally put on wire by a dedicated set of messenger threads. And those guys are also responsible for freeing the memory. So very likely we will need to handle the allocations from different threads. Hopefully, yep.
Does it make any sense to implement two different versions, one of which does not require the deallocation to support a separate threads, and one that does? Or do you think we can handle it all with one that's still fast?
So can you repeat, please? I cannot understand.
Does it make any sense to have a non-thread safe and a thread safe version?
Ah, I see. I don't think so.
Okay.
Actually, it comes of how the guarantees buffer list gives you. There is no restriction on that buffer list can hold only PTR nodes across one single CPU domain. It's already there are already guarantees that you can reference remote pointers as well. To exemplify, the buffer row reference counter is atomical.
When we were talking earlier, you had made during the stand-up, you had made the point that we don't need atomic pointers for the positioning inside the circular buffer, and I didn't understand why that was the case.
Okay. Mark, we were considering yesterday. We were talking about a design that was about two atomical pointers in control block. Let's say the main control structure, plus a bunch, plus one atomic per entry to form a list of entries to free. This is necessary because, well, the allocations can happen in different order than the allocations, and we need to take care about that. So the extra pointers, the extra atomical pointers, one pointer per entry, were intended to form an ordered list. If somebody deallocates out of order, then the entry wouldn't be reclaimed. By reclaiming, I mean updating the, let's say, the tail pointer of ring buffer. It will be put on some kind of shelf. Yesterday, I was thinking about having this shelf implemented as an ordered list. Order will be formed by addresses, but this night I understood it's actually reinventing a wheel, because we already have ability to logically we already have the list. There are no pointers, there are just sizes, but having the information where the buffer, when the ring buffer starts, we can very easily compute the boundaries of those entries. And moreover, they are already ordered by addresses.
Okay.
We don't. That's funny. We don't really need. We don't really need the physical list. The order is already.
Sure. Okay. I think I get it.
And we can compute. Pointers, addresses of each entry just by adding the sizes of previous entry, beginning of tail. Just take a look on the deallocate part of the snippet. There is a while that calculates new tail.
I see. Okay.
Well, I haven't implemented that yet. It's still I'm still entirely speculating. Very likely, I'm wrong. But well, I'm going to give this design a try, and we will see. Practice will show.
Yep. Do you end up having, if you don't make assumptions about like whether or not something could have been deallocated out of order, Well, yeah, you already have it ordered that way. I was just trying to think of what mechanism you use this, how much you have to walk to be able to figure out where the new tail is. Um, I'm looking at your while loop here, I guess.
Well, if we are happy and if the allocations happen in proper order, then I actually don't need to walk. I never need to walk. There will be only single one single iteration of the nested loop.
Okay.
Just
Okay.
for the PTR that we set to needs reclaim.
Sure.
That's
Because
the primitive flow.
Yep. Because you may be able to go much farther in, right? Like you might have more
Yes,
space than
in
you think you
case
do as soon as, yeah.
exactly in case where there was out of order the allocation, I actually cannot move the tail pointer, the tail offset. I need to wait. But I need to mark that this particular entry is, let's say, semi-dead. It cannot be it cannot be reclaimed yet because there is a previous entry that is still alive. But
Yeah.
yeah, but I have it. I'm keeping it marked on the memory for the situation where the previous guy that was alive but now it's dead will be reclaimed. So in such
That's
situation, the loop will take will reclaim both entries.
that's fantastic. That's much better.
We'll see. We'll see.
I agree though.
I'm not sure. I haven't implemented this yet. I haven't run the unit test for buffer list. It's just purely speculative at the moment.
Okay. Well, I'm super excited about this, Radek. I think this is going to be this could be really good. Don't want to say
Well,
more until we try it, but I'm
yes,
excited.
we are making huge bet that TC malloc does a lot of pays a lot for being generic, for handling generic case, for being a generic memory allocator, for being POSIX compliant. We don't need to worry about a lot of issues that TC malloc has to do. And maybe we could leverage, but still I don't have even a single idea about the real proportion between essential work and, let's say, the payoff for genericity in TC. I don't know. I'm purely experimenting right now.
Radek, in the Etherpad, I just repasted the one from the MDS, the call graph from the MDS that we were talking about earlier, where we can see directly from buffer raw combined create the TC POSIX memo line and the third cache fetch from central cache all.
Oh, sorry, I was muted. In TC, for TC, we already saw that usually it's super fast, but when it comes to shuffling memory between per thread, between local thread pools, the things get nasty.
Yeah, well, the fetch from central cache, right? That's the thing that's really bad because it's a high overhead, and I think it's just a central lock there, right, as well.
Possibly, I haven't. That's my problem. I haven't drilled through TC malloc implementation.
Sure.
I'm making another assumption that there is actually full locking happening on allocation and freeing when you have done in cases when your local cache is out of memory or during the allocation when it grows too big, and you need to put something to the central one.
I'm very hopeful. I think that having the knowledge that we do about how we're allocating in these threads and deallocating, and also that at least in some of these cases, or even in the majority of the cases, we know that this is short-lived. I think we can do much better. We'll see.
Anyway, by the way, we already have a bunch of we already have some benchmarks for buffer list appending, micro benchmarks. These ones in unit test _ buffer list, and they could provide some information. But we need to keep in mind that unit test is, as far as I remember, it's linked with the libc allocator. It doesn't use TC. But
sure.
I was taking a look on libc allocator, and I'm pretty sure it logs on every call. So it could resemble a little bit the TC behavior in the situation that we are interested in.
Okay. Well, I will anxiously await your continued work, Radek, and as soon as you've got something, I will absolutely make use of it to run some tests. So we'll see how it goes.
We'll see. I won't be surprised if we throw away the entire solution through the window.
Maybe we'll see.
We'll see. We are experimenting.
Yes. All right. Any comments, guys? Any questions? All right, then let's move on to collection list performance issues. RocksDB. Niha or Igor, do you guys want to take over on this one?
Yeah, I can start. So, well, actually, that's a pretty long story, but, well, I originally met this issue more than a year ago, and it reappeared multiple times since that time, and at different customers and in upstream reports. The main issue is probably that RocksDB might behave pretty slow after massive data removal. And after that, potentially it might happen for different operations, but most often it was met for collection listing, which is list of objects per PG or per collection in BlueStore. This is so. From my experience, sometimes these, some user for BlueStore, I mean some upper layer, trigger limited collection listing, say 30 items to retrieve and perform subsequent removal or whatever. This is a synchronous operation from BlueStore point of view, and sometimes it might take several minutes if RocksDB is in a bad shape. And as a result, OSD might be killed by suicide timeout. Well, definitely we can, yeah.
When you say RocksDB is in bad shape, you mean that specifically RocksDB is blocking because it's doing some kind of internal compaction or other workload?
It's not blocking, it's responding very slowly.
Okay.
The major workaround for that, known so far, is manual compaction for RocksDB. This helps 100% of times, but that's a temporary solution as far as I can say.
If compaction is helping, is this related to the same iterator like fragmentation thing that we see in other cases where you've got like tombstones that are causing it to be very slow?
I think so. So it's definitely related to these tombstones in RocksDB. Maybe I've just got an idea shortly before the meeting that RocksDB pages mention that some resources might be pinned for a while by iterators, and there are some chances that we somehow prevent RocksDB from running the compaction, and so something grows in memory or whatever, and until we restart the OSD and do the manual compaction, it might behave slow. So
and we saw some issues with like holding iterators open for too long extended periods of time due to that kind of thing. Are you thinking that this might be part of what we're running into?
Well, I'm not completely sure about that. That's just a hypothesis that I just got. Another option is that we so pretty often I've seen this issue when there is massive load from clients, and maybe it's simply a mismatch of real performance of BlueStore and client load. So in some cases, I've seen that for when OSD, well, DB was on spinners. This is definitely a bad setup, as I can tell, but I can't say that. So I've seen the same issue with better configurations, which have SSDs and NVMe drives to backup to back DB. But well, there are some chances that just a mismatch, so that BlueStore or RocksDB are simply unable to handle this high load and handle the load and compaction altogether, and hence.
Igor, this is Ben. I just have a quick question, if it's okay. Does any of this have to do with the size of the OSD? For example, is it more likely to happen if you have, say, a 10 terabyte, OSD than, because typically in the performance tests that I see running where I am, typically they're with very small devices because we're too cheap to buy the big ones. And I'm wondering if there's any correlation there.
Honestly, I see such correlation between the data set size and this issue. As I said, it's rather when there is high load from clients and or massive removals prior to this issue to happen. So, well, my primary goal is to make sure that we as developers are aware of this issue and maybe think how are we going to resolve this, or at least make workaround, implement workaround in an automatic manner or something like that, if we can fix that.
Igor, do you think there are like clear client workload profiles that can make this worse versus not? Like, are there like correlations there?
Well, first of all, RGW, so this tend to be a RGW issue, or at least it happened more frequently in cluster which handle RGW load. That's primary. So.
Does it have to do with
Basically,
small objects?
smaller objects. Okay, yeah, we said the same thing.
Small objects or plenty of map entries or whatever. So as you should know, RGW produces much more load to RocksDB compared to RPD and things like that, and that's primary
If it's due to slow iteration due to tombstones, you'd expect that the more tombstones that you have due to the more load, the worse the problem gets. That's what we saw with range delete. Igor, do you have logs, like OSD logs, for any of this?
Well, there is a ticket in the tracker which mentions 2 more tickets about this. I can say there are much interesting in logs there, but well, honestly, I don't remember how what's there in these logs since these tickets were collected for a year, and I don't expect much just in the logs. So a while ago I implemented some additional logging in Blue Store to track flow operations. Well, this might be a sort of indicator, but well, to get more details, you might need logging at RocksDB level or something like that. So at Blue Store, we just can see that some iterator increment is just slow or that.
I see that there were logs in one of these. I was wondering if we might be able to see compaction event history.
Well, one more note here. I can't say for sure if this is correct, but it looks like we need offline compaction to work around the issue. So it seems that some folks tried to do online compaction. We have a command in admin circuit interface, and it didn't help, which might be another proof that we hold some resources by iterators or something like that. But again, I'm not completely sure that's true. And unfortunately, I've never been able to reproduce this slowdown locally. So I've seen multiple complaints about that. Well, it's known that compaction helps, but well, the most interesting issue was for Salesforce, as far as I remember. So they triggered some massive pull removal, which worked for a while, and then cluster has gone to almost dead state. And so OSD restarted at some point, and even compaction didn't help because removal was still running, and hence we need to remove some data manually from database to stop this background removal. And there were no, well, actually there are no way to control it once we started this removal. So all these things happen pretty, so they are pretty unclear. There are no proper indication. We get OSD restarts at absolutely different locations, like OSD thread, but the root cause behind is slow database access and some suicide timeouts or some artifacts from that. Well, I am pretty sure we don't have exact solution at this moment, but just wanted to share this information to everybody aware of it. Maybe, well, probably we should have a sort of brainstorming one day how to deal with this. Well, something stupid like compacting OSD every night. I know there was a recent commit to form compaction on OSD restart as another attempt to fight this issue.
Igor, I thought we maybe periodically did do background compaction. Maybe I'm wrong on that though. Do we only compact when we have enough write ingest?
You mean we run some compaction on our own from OSD?
Yeah, I mean, it would be easy to do. For some reason, I was thinking we did do that already.
Well, we have an API for that, definitely. We do not perform that periodically, as far as I know. But, okay. Well, as I already mentioned, I'm not sure that online compaction helps, but well, I don't know. I have seen some notes that it doesn't help. That's manual compaction offline manual compaction, which helps.
It definitely helped for the range delete issue, where we had whenever RocksDB finally got around to doing an online compaction, you'd see performance go way up, and then it would very quickly degrade again as soon as you had enough tombstones present.
Well, I recall one more note from one of these tickets about the duration of such compaction, which takes 30 minutes, and hence it might be not a good thing to run at every time.
I bet it's only taking that long though because so much is accumulated, right?
Well, they're stating it takes that long each time they run, no matter. Well, I think they are not absolutely correct here. So it might depend on the duration before the compaction. So most probably it doesn't take that long if you run it, well, once a minute, for example.
Well, that's exactly what I was just thinking. Is like once a minute. That sounds like it wouldn't be. That might actually be the right way to go.
But, well, at least in the ticket they mentioned it takes that long. And by the way, let me share the ticket. Yeah, here is the ticket which was created recently, but it has two more references for two more tickets. So again, I think there are two possible causes for this. The first one, we pin some resources and prevent database from doing compaction in time, or it's a sort of mismatch between the load and the key store abilities, and we might need to throttle.
Igor, I put a link in the chat window.
Yeah.
RocksDB introduced. There's a PR that was introduced to perform periodic compactions on column family.
Mm-hmm. Yeah. Well, then the question is, if the issue is caused by resource spinning, it probably wouldn't help, as it didn't help for when issuing compaction from admin interface. I think we should start investigation with the repro for reliable reproduction for this issue. Then we can search for solutions, because we can enable multiple features like data prefetching and this periodic compaction, but the response time for these solutions is pretty long. So I mean, when customer actually face the issue, we get the understanding that this or that fix didn't help.
Yeah. Do you know that whether or not what that workload was like? Were there a lot of writes involved when they were doing it, background writes, or other things going on?
Well, can read what they mentioned in one of the ticket, which is 45,765, and the last comment says we don't use RGW, we use self-written client which operates with small objects. Load is not that high, about 200 read operations per OSD and 50-100 write operations per OSD during normal operation. It uses plain Redis objects, no map. Works perfect most of time. We faced with this issue when we tried to move some PGs. And yes, manual compaction helps in our case. Yes, it always takes about 30 minutes.
So when they moved PGs, that was when it got bad?
Well, that's again triggers some data removal as far as I understand. Source.
Yeah. Yeah, data removal, that's the question, right?
We've seen
It
a
was
couple of
during,
instances in our internal testing, where pool deletions have been taking forever, and that has been highlighted multiple times. So I wonder if that is some use case that we can try to reproduce. But you'll have to have a lot of pool deletion, like a lot of data in your pools.
Would you
we do,
actually have to have
and
a lot of
we
data
don't,
or just a lot of objects?
Yeah, I mean, a lot of objects in your pool. So we've seen it mostly in RGW pool deletion,
Neha, we
especially.
don't use range delete there, right?
Nope, nope.
Okay. I wonder a little bit if we need to trigger compaction after a certain number of deletions happen, at least in certain scenarios, maybe. Well, anyway, yeah, Igor, I think you're right about deletion. I suspect that that is maybe the thing that really triggers this.
Well, another note. I've just realized that all these 3 tickets we have in the tracker, they are for Nautilus, and even not the latest Nautilus versions. So I can say for sure what was the versions for other currencies. Maybe in Octopus we're in better shape. So, but if someone faces this issue with recent releases, I'll appreciate if you share this information just to make sure that we are not fighting with some old stuff.
For reference, here's the delete range PR and discussion from last November. And that was backported to Nautilus, but I wonder what version they're on. 14.2.7.
Well, I can see.
No, we reverted that change, so Nautilus also doesn't have it enabled.
But I'm wondering if their version of Nautilus is older than that.
As far as I know, we never released a version of Nautilus which had this enabled. It was just
Okay.
temporary. We removed it very quickly.
Okay. I saw there was a backport on January 30th. So what did we have before that in Nautilus? We reverted the changes in 5183. So Niha, in Nautilus before 31442, we never had applied the change that Casey made that that enabled the RocksDB delete range.
Trying to see where we actually. I can see the revert PR was merged in the end of November. Let me link it here.
So presumably, also the balancer could really make this bad, right? If we're creating or destroying PGs on a semi-regular basis as things change. Not the balancer strictly, I mean the balancer, but more the autoscaler.
Yeah, but the only good thing about the autoscaler is it doesn't make changes too often, right? So it's only if there's 3 times the difference in what things when it should make changes, will it make changes, right? So
well, but as soon as it makes a change, it would invoke this behavior, right? If it's deleting PGs, you would potentially then end up in a situation where everything's like falling apart behind your back.
yeah.
Not due to any specific fault with the autoscaler, just the interaction.
I mean, the other thing to note is that 14 to any versions of 14 don't have the autoscaler on. So at least for Nautilus, we're not seeing that play a role.
Yeah. Okay, so this person, Xiaoxi, is saying that, but we are in Nautilus also seeing that RocksDB overhead during snap trim is huge. We work around by throttling snap trim speed to minimal as well as throttle deep scrub.
Yes, we are running over time, but I think to summarize it, what Igor says, I agree with it. We need a reliable reproducer before we try to, make changes and dab in the darkness.
Yeah, I agree. All right, well, as you said, we're over time, so thanks, Igor, for bringing this up. It's a little scary, but hopefully we can figure out a good test case and make some progress on it.
No problem.
All right, well, have a good week, everyone. See you next week.
You too. Thanks, everyone.
Bye.
Thank you. See you soon. Bye.
Bye.